Alright, so today we're exploring growth hormone, also known as somatotropin, a hormone that plays a critical role in regulating growth, metabolism, and cell reproduction. From its secretion in the brain to its wide ranging effects on the body, let's dive into how this fascinating hormone works. The secretion of growth hormone is controlled by the hypothalamic pituitary axis. It begins in the hypothalamus, which releases growth hormone releasing hormone, GHRH, into the hypophyseal portal system, a network of capillaries connecting the hypothalamus to the anterior pituitary gland. In the anterior pituitary, GHRH binds to receptors on somatotroph cells, stimulating the release of growth hormone into the bloodstream. Growth hormone secretion follows a pulsatile pattern, with levels peaking about an hour after sleep begins and responding to stimuli like exercise, puberty, and low blood sugar. Growth hormone release is tightly regulated by multiple negative feedback loops. High levels of GHRH signal the hypothalamus to stop its secretion. Tissues like the liver produce somatomedins, which signal the anterior pituitary to reduce growth hormone production. Both growth hormone and somatomedins stimulate the hypothalamus to release somatostatin, also known as growth hormone inhibiting hormone, which suppresses growth hormone release. Interestingly, somatostatin is also secreted by delta cells in the pancreas, where it inhibits the release of insulin, glucagon, and gastrointestinal hormones. However, somatostatin released in the hypothalamus and pancreas act independently of each other. Growth hormone stimulates growth and metabolism through both direct and indirect effects. Directly, growth hormone acts on adipose tissue to promote lipolysis, breaking down fats for energy. In the liver, it increases gluconeogenesis, or glucose production, and glycogenolysis, the breakdown of glycogen into glucose. Additionally, growth hormone reduces the effectiveness of insulin, leading to increased blood glucose levels. This effect is called diabetogenic, as it mimics the condition seen in diabetes. Growth hormone's indirect effects are mediated by insulin-like growth factor 1, IGF-1, a type of somatomedin produced by the liver, muscles, bones, and kidneys. IGF-1 binds to specific receptors on cells to promote metabolism, prevent cell death, and stimulate cell division and differentiation. In muscles, IGF-1 increases the uptake of amino acids, boosting protein production and promoting muscle growth. This is especially important during the growth spurts of puberty, when IGF-1 levels are highest. IGF-1 is also key to bone growth, acting on the epiphyseal plates of long bones to stimulate the activity of osteoblasts and chondrocytes. This drives the elongation of bones during childhood and adolescence. Here's a quick question. Which of the following hormones inhibits the release of growth hormone? A. Growth hormone releasing hormone, GHRH. B. Somatostatin. C. Insulin-like growth factor 1, IGF-1. D. Both B and C. Pause the video to think it over. The correct answer is D. Both B and C. Somatostatin directly inhibits growth hormone release, while IGF-1 provides negative feedback to suppress its production. To recap, growth hormone is released by the anterior pituitary and regulated by GHRH and somatostatin. Its effects include direct actions like lipolysis, gluconeogenesis, and increased insulin resistance. Indirect actions mediated by IGF-1, which stimulate muscle and bone growth. Together, these mechanisms promote overall growth, particularly during puberty. Want to deepen your understanding of growth hormone and other endocrine topics? Visit kotc.me for practice questions, interactive tools, and detailed explanations. Thanks for watching, and see you next time.